Mr. Don McRae.
Yeah.
After this, we will have our Producers' Council presentations, which will be initially held, the first section in this total room, and after this, I think we will subdivide our three sections. And we have three concurrent slide presentations. We would like to keep the crowd a little bit smaller, so there's indeed some personal interaction right after the slide presentation. That personal interaction, the discussion or the seminar in connection with the slide presentations will be conducted by members of the Producers' Council. A number of the sponsors of the Producers' Council presentations are here with us this afternoon. Last, not least, we will talk again about solar energy, and Professor Fuller Moore will be our speaker, scheduled for 4 o'clock. It is a real pleasure to introduce to you Mr. Don McRae, who is the Commissioner of the ABC, the Administrative Building Council, a body which is responsible for codes and their enforcement. Mr. McRae is a professional engineer, a fellow of the ABC, and has a very extensive background in a number of fields. In architectural engineering practice, and he headed up for a number of years, 13 years, professional offices. He worked for 5 years to start his career as a structural engineer, was in fabricated steel design, also sales, and on top of this was involved in a number of community and state organizations. He is a graduate of the Michigan College of Mining and Technology, Michigan being his home, and he moved to Indiana now about 25 years ago. He is setting up the ABC since a relatively short period of time, just about a year. He has done a tremendous job in responding to this new challenge. And I think that will be the major focal point of his presentation this afternoon, to talk about the challenge the code official is faced and the challenge the architectural profession, and particularly the architectural student, is faced to respond to the tremendous need we are faced with, the challenge of energy. Without any further ado, Don McRae.
Can you hear me all right? Does that work? Hey, great. I can use my hands. Hi. Professor, I'm not only gratified but flattered that you asked me here today. I'm gratified because I welcome the opportunity to talk to students and to the certain members of the practice who have come today to learn something about solar energy but don't need much instruction on the code aspects. When I was a kid, in my real early teens, we used to summer up in northern Michigan at a church assembly of cottages that brought in people from all over the country. I remember the kids that I associated with and played tennis with in those early years were from Kokomo, and they were the only people I ever knew from Indiana, but their standard greeting in those years was hi, hi. I thought that was great. I guess that's one Indiana custom I picked up early and kept throughout my life, that word hi. But at any rate, I've been a Hoosier for 25 years, and I thought when I first came to this state back in 1953 in a sort of a selling capacity, and I ran across a great conservatism on the part of owners in what they thought they would like to build and what they wanted to buy to put into those buildings. I thought for a while that they just hadn't caught up, that the war years and the Depression had set Indiana back a few years. And I thought, well, given time, they'll catch up. I finally came around the Hoosier way myself. I find that they're not going to go the way of many of the other more eastern states. So I've become a Hoosier, I think, truly, where I can settle down and think the way people do a great deal in business. And that gets us around a little bit into this code and standards problem or situation. I was here briefly this morning. I was a little late in arriving and hearing Mr. Kibler's presentation of the energy program as it affects Indiana and what Indiana is doing about it. Of course, we've listened eagerly to President Carter's speeches to find out if he's going to shed any new light, but all he's doing for me is throwing out some more questions. Obviously, what he's telling us on the radio or on the television is what he would like to see done, and what results from his messages remains yet to be seen. So from the state standpoint, I guess we're just going to have to make plans as best we can to do what we can until we get some specific directives. However, there are some very specific things on the horizon. I think before I start getting into exactly where we're headed on this energy conservation program, I better tell you just a little bit about codes and standards and what they mean. I think it's necessary that we distinguish between a standard and a code. I belong to a national group that's made up of people like myself, of building commissioners and building officials from leading cities and states. And I was sitting in a board of directors meeting of that group with perhaps 18 to 20 people, and we got on the subject of the American National Standards Institute, which is known as, by its initials, the acronym is ANSI. And we got on the subject of how important it was that this new ASHRAE 90 be subjected to the consensus procedures to be adopted under ANSI as a national standard. And we went on and on about listening to discussions on this thing, about the pros and cons of the necessity to do this, and finally one of the commissioners from one of our leading states said, "For God's sake, what the hell is ANSI?" So I guess the conclusion I had to draw from that I felt a little bit less inadequate on my own part for not truly understanding, but also appreciation that people, even in the industry, in the practice of architecture and engineering and the design arts and supply, also lack an adequate understanding of what a standard is and exactly what a code means and what the difference is. A standard actually is a way of doing something set by a performance to meet a certain performance requirement. It's the prelude, for example, to a testing procedure that says if you're going to test or judge my product, these are the standards that you ought to apply uniformly wherever you meet this particular product or need, so that it gets uniformly done. For example, we have, for example, a manufacturing or a business standard where the manufacturer of a air conditioning unit will set certain standards to be followed by his people in designing and building the unit that comes out of his factory. Then we get into an industry standard where all the air conditioning manufacturers will get together and decide there are certain things that they ought to get together on in order to make the products interrelated in use and make it easier for designers and in sales. And so we have industry standards as against the manufacturer standards. Then we get into governmental type standards where the government decides what standards ought to be applied. And that is a mandated thing. Ordinarily, the government likes to go to the people and go to the industry and trades and the professions, and before they set a standard, sometimes they fall a little short, we think, in what they finally come up with and say, this is what you're mandated to use as a standard. But that's a governmental standard. Then we get into what's called the consensus standards. And I think that's really the ones that we're facing into, not only in the energy conservation bit, but we're facing into it in all of building regulation. We tend to use consensus standards. Now, what they mean by the word consensus is that somebody will propose a standard to be used, a bunch of guidelines, a whole group of guidelines to be used for a building purpose, or how a brick wall should be laid and tested, or a piece of equipment or whatever, in the way of performance. Then they will submit that to one of several groups. The leading group today is the American National Standards Institute, which I indicated was known as ANSI. who have a great number. Now, this is a not-for-profit, non-governmental group of people made up of industry spokesmen, professional spokesmen, industry of all kinds, who are delegated to committee functions within a special area of expertise. And they'll take this proposed standard and work it over and make suggestions, and they'll talk to people about it, and they'll finally they'll send it out. A draft form will go out to every possible conceivable user of such a standard. It's a long, lengthy process, but all of these potential users have the right to submit their ideas about it. And after it goes through this whole procedure, it'll be submitted for a final review, and then it's adopted as a national standard. Then it gets listed as a standard, and it's published. And that is the standard for that particular product, and that's called a consensus standard. Now, essentially what a consensus standard is then is a performance-related thing. Now, the reason I have to go specifically into those words is because we talk about codes and standards sort of synonymously, and people often don't realize the difference. That a true code, for example, is put into language that is legally enforceable. It's got to be the type of thing that a person can look at. It can be inspected. It can be measured. It's a set of things that you do. Now, it's based on standards. Now, a true code, then, you'd say would be what we call a specification code. That, in other words, you don't say what a particular piece of equipment is supposed to do. You say, this is the way you do it. As against a performance thing that says, hey, what we're trying to do is create a situation that will take care of such and such a condition. Now you're free to go ahead and develop an answer to meet that condition. Now that's what we really call a performance standard. On a little bit of thought, it might be obvious to you that a true specification code just won't work, because there's no way you can publish enough Sears Roebuck-sized catalogs to cover every conceivable situation that might arise in the course of the architect's work or the builder's work. On the other hand, if we went to the full performance route, we'd all have to have equivalent professionals to check out the results of what's going on and make individual judgments as to whether or not it meets the intent of the standard. Obviously, a pure performance code is rather unenforceable. So we talk about specification codes, performance codes, and standards, and you can see they're all kind of related together. Now, traditionally, building regulations come about as a result of a quest, if I can use that expression, for protecting public safety and health. Public safety probably in two broad ways. One is the life safety, which refers to structures and safety of the structure. And the second, of course, is fire safety, which protects against the ability of the people, of the occupants of buildings, to get out of that building in a safe manner. Of course, there's other reasons for building regulations, and of course public health, having to do with the contamination, not only of air but of water, of the spread of fumes, for example, that might endanger human health. The early history of codes and building codes in the country, of course, always goes with disasters. Nobody gets up enough effort to get out a new code requirement unless somebody's lost a life, or unless there's been a big disaster, an earthquake, or a huge city fire like the Chicago fire, or some years ago, back when I was in my early professional years, it was a Coconut Grove fire out in the East Coast that 600 or 700 people out for the evening in a ballroom were killed because they couldn't get out. Those things happen. After every one of those disasters, there is new pressures for building codes. But they're traditionally been based on the need for public safety and public health. Talking to Harry Egging during lunch, who has spent some time now, most of you who are students here are aware, on the continent, in Germany and Holland and in Switzerland. And the use of codes over there is to some degree different than in this country. A great deal of emphasis put in Europe on codes as a protector of aesthetics, for example, of visual appearance, also of the protection of people's rights as far as visual appearance is concerned. They're going in a great deal more than we do here on historic preservation matters in making sure that things aren't destroyed that have historic value. We're starting to get into that type of thing in this country now. So, and zoning is of a great deal more emphasis, and I imagine written in the building codes in Europe than they are in this country. In this country, zoning is still a highly controversial subject in many areas. It seems to be the further removed it gets from the federal government, the less accepted it becomes. I don't want to destroy anything your professors are telling you in the school. I better say rather cautiously some of these things that I've observed in my lifetime. But at any rate, the idea of writing into mandatory legislated codes requirements for things other than health and safety gets a little difficult. We're now getting into an area where the needs and the highly publicized needs for energy conservation has created enough public awareness of the need, as Mr. Kiley pointed out this morning, that finally after about 3 years, our state legislature agreed to pass on authority for building codes, for us to incorporate into building codes certain requirements that will protect the community's interest, that is the country in this case, in the conservation of energy and the functioning of buildings, without a single dissenting vote, I might add. So we now have in Indiana, along with some other states, more and more states, for reasons I'll explain, are adding this authority into their building codes. Another one I'll just mention in passing is building security is one I hear in national levels when I'm dealing with the larger model code groups and with federal groups, that the need for security is becoming acute in many areas, and there's a great pressure on by building owners, for example, and insurance companies and property owners themselves to be provided with guidelines that will require, if you will, their buildings to be built basically initially with an eye towards the security of the building itself and its content. We have not in Indiana got into that, and there's not even any discussion of it, but I do find discussions in other areas where the pressure is really on by the community to have those guidelines furnished to them for building security. So, back in 1973, in anticipation of energy conservation needs in the functioning of buildings, the Department of Housing and Urban Development, which we refer to as HUD, those of you who haven't heard of HUD, you might as well get used to that term pretty quick, so I'm going to refer to HUD, and that's the Federal Department of Housing and Urban Development, sent out a request to practitioners, to trade groups, to come up with a set of standards for energy conservation in the use of buildings. The National Bureau of Standards rose to that bait, as did a few others, got together with another newly organized group known as the National Conference of States for Building Codes and Standards to see what they might be able to do in developing such a standard. The American Society of Heating, Refrigerating, and Air Conditioning Engineers, which is known far and wide as ASHRAE, responded, but the final submissions in draft form and proposal to HUD put the ASHRAE proposal way out in front. Now, ASHRAE protested a little bit and said, we're not organized to do this kind of a job. We're a trade association, but we're really not constituted to do this kind of thing. But they did such a superior job that the National Bureau of Standards made a little kind of a threat, and they said, well, if you don't ASHRAE, then we're going to. And I think that that threat of having a government body get into the standards field prompted ASHRAE to go ahead with their bid, which was a good thing because it resulted in a document which was known as ASHRAE 90P, the P standing for preliminary, which proposed a rather detailed set of standards for the design of buildings with the interests of energy conservation as its basis. The government then took that, HUD took that, reviewed it, scrutinized it in every way, and then submitted it out to some testing organizations that say, hey, try this out and let's see what happens when you actually apply these standards in the way of conservation of energy. One of the organizations that was given that testing job was an organization known as Arthur Little Company, which is a think tank group out in the northeastern part of the country, who took 5 prototype buildings. They were a single-family detached residence, a low-rise apartment building, an office building, a retail store, and a school building. Then they applied those 5 buildings in 4 different parts of the country, so they get into different climatic areas. And then using those prototypes, they made a study of what the energy uses would be for those buildings under conventional construction. And then they applied the test of redoing them. They didn't build the buildings, this was all theoretical, of what the energy uses of those same buildings would be. Did they apply the standards promoted by ASHRAE 90? And they came up with some very detailed results in a very lengthy report, which boiled down into some very interesting factual matter. For example, that every one of those kind of buildings showed significant savings in their fuel. The highest savings being in the office buildings, the lowest in single-family residences. But all of them showed savings. Of course, for people who are conversant with the amount of effort that goes into designing a building with these additional requirements, you realize they had to take a great deal more design effort to apply that ASHRAE 90 standard. So we got into additional design costs on the parts of the architects and of the heating and ventilating and electrical engineers that became a part of the design effort. So we found even, however, adding the design costs in and taking advantage of these theoretical energy savings costs under the current fuel rates, that there remained only a minimal difference in the additional cost of producing energy conservative buildings. So that sort of answered the question on a theoretical basis of, is it going to cost an owner more to build these buildings? Now, there's a big hassle going on now since, well, let me go on with that line of reasoning. After all these studies then, ASHRAE 90P became ASHRAE 9075, 75 pertaining to the year, no longer preliminary, which doesn't mean that it was fixed because it's not been adopted as a national standard, although it's in that process right now of being adopted as a national consensus standard. But now we get into the code writing groups. Who writes the laws based on these standards? Well, the answer in this country is that the codes are written by, most of them are written basically by one of 4 organizations. 3 of those 4 are industry groups of practitioners and building officials, tradespeople, professionals in a joint effort. The 4th one has to do with a group of insurance companies who deal principally with major cities, their code being primarily used as a basic text for those who set out to write their own codes on an individual basis. That's the national code. It's the oldest set of building codes in the country, but not active with the other 3, which I say are non-governmental, not-for-profit groups. Under the umbrella of this National Conference of States for Building Codes and Standards, those 3 leading code groups then received a grant from ERDA, which is the Energy Research and Development Administration. acting for HUD. And having a code written based on the ASHRAE 90. And instead of having 3 or 4 different codes, the 3 major code writing groups then would come up with a single proposed code, which could be used by states or by communities in pursuing these objectives. The result was that in January of this year, the so-called model code was developed and issued in a review form. So the proposed code that will be used to some degree or another throughout the United States will be based on this model code for energy conservation and building construction, a new building construction. This is now out for review by the people who have received the grant. The goal is that it will be revised, brought up to date, and turned over to ERDA as a final product about the 1st of July. ERDA will then pass it on back to HUD, and where we go from there will be interesting. Up to this point, I've been assuming that states and communities that have the authority to promulgate and enforce such codes will have the right to go ahead and do so without further pressures from some federal agency. However, my thoughts at that point do not govern the situation. It may very well be that HUD at some point in time may decide that they'll issue these as a national code, preempting any of our rights to do what we want to for our own states or for our own communities. I hope that will not be the case. I like to think that in some of these areas the federal government is learning a few things because they've had some pretty sad experiences with these types of standards that have been promulgated out there without consultation. We are going to prepare in the state, however, of Indiana to promulgate this code or some variation of it, probably some variation of it, hopefully small, for the state of Indiana when the time is right. But it is based on ASHRAE 90 standards. And many people have said, well, all it is ASHRAE 90 in a different kind of a form. Well, that may be. Currently, it sees 3 ways of applying energy conservation requirements for new buildings. One of those being a theoretical approach, which, for example, would assign to any specific kind of a building an energy usage rate that the architect and the engineers could work with and say no matter what they come up with in the final product, that building, if it meets that certain fuel or energy usage, will be acceptable. Now that would be almost a pure performance type requirement, but ASHRAE 90 or the model code does address to that group, to that effort. The second breaks down the building into component parts, what they call the building envelope or the shell, the structure itself, and into the heating, ventilating, electrical requirements, each on an individual thing, setting up standards and performance requirements trade by trade. The third is a pure specification approach which is used for owners in small buildings, which they can go to tables for and bring out certain U-value requirements for insulation of walls, for heat capacities of walls, roof ceilings, and so on, and come up with a stylized energy conservation approach that if they do those specific things, then it's okay. So right now the code adopts itself those 3 things. Now out in California there's a very interesting hassle going on because several of the states got into this energy thing before others, and California was one of them, and I think what they did was they came across full tilt. Instead of waiting for a code, they adopt ASHRAE 9075 as the state code, and it's meeting all kinds of resistance. And the courts, for example, have ruled in California that nothing's going to be done until it's been reviewed, certain answers found, but it's too wide open, apparently. I don't know all the facts because the facts confuse me, so don't hold me to that, but in general, there are problems in the country about this energy conservation matter. Hopefully, as we go on month by month in the development of these things, we'll do it in an orderly fashion so that the federal bodies don't find it necessary to intrude on the situation and say you're not acting fast enough or thoroughly enough, therefore we're going to do it for you, which is generally what happens on these things where we drag our feet. So we are equipped with the model code here. We have the authority, and we'll have to develop some staff. Now, the timetable for Indiana will be something like this. No, I haven't finished my discussion yet. I've got to tell you a little bit more. We can't just hit the public cold with a brand new, complicated set of code. We're going to have to tell people what it's all about. The federal government has helped us again through the National Conference of States for Building Codes and Standards. They gave grant money to study and set up an educational and training program for the application of this model code to the users. They've worked up a 4-part educational training program for building officials and the public. That program, the whole curriculum and course content has been prepared. It was prepared as of January. It's now in a testing procedure throughout the country in 4 different states to see if it does the job. It'll be reviewed, rehashed, and brought up. Those programs will be turned over with some help to the users, to the state of Indiana. It will be up to the state of Indiana to implement the training functions of what's been prepared. It's our intent to set up a training staff which will take these programs out to the users. We're talking about as many as 8 geographical centers, perhaps, for the basic training parts, where building officials and local people, builders and so on, can come on an easy drive, a 1 or 2 hour drive, and sit in for a day or two to find out what it's all about. There's 4 parts to that program. The first part's real easy. It's only a 1 hour seminar kind of a thing, which tells public officials and the general public about what we're trying to do. I haven't seen any of it. I've just seen synopsis of it. Now, the 100 series is a 16-hour program set up for inspectors who will know what to look for and understand basically some elementary principles of heat transfer. And we'll be able to go out and check a set of plans, with construction against a set of plans. That's a 16-hour program. Then we have a 21-hour program, which is set up for plan reviewers and building officials. We'll go a little bit more into details on heat transfers and thermodynamics and the use of the codes. And the last one is set up for people like yourselves, most of you, architects and engineers and the professional public, which will be a 31-hour program. I imagine that'll probably take 4 to 5 days to put over in its entirety. And just how we're going to conduct that so everybody will get into it, we'll have to see. We'll probably call on the school here for their help and suggestions. We'll get together with the community colleges. But at any rate, I have to staff up to do this. I have to also appoint a director. I want to find a director for energy conservation programs to work out of our office who will take over this entire correlation effort with the national bodies and within the state. What I really would like to do is avoid adopting a code until we've had some dissemination of this educational program in the state. I believe on the present outline we're to start implementing the educational efforts by the 1st of October. The size of the audience out there, which I aggregated around 2,000 people of different types, I think is going to be a 6 to 8 month effort, which means that sometime along about late spring of 1978, we will have completed that phase. Now, I don't want to wait that long because there are other pressures to get this code adopted. What I'd like to do is along about February or March, start advertising hearings on the code after we get a knowledgeable public who will know what was being proposed in some detail. And then start having hearings for code adoption with the idea that maybe along about June or July of next year, we'll have a code adopted and ready for implementation. At that time, at the state level, we will have to probably add some plan review staff, and we'll probably have to add some more inspectors to our group to handle the results. How big that's going to be, I don't have any idea. I think it's going to kind of come as a shock to a lot of people that sometimes the big problem is not heating buildings. The problem is getting heat out. great deal of the things we're hearing and reading about have to do with how do you heat this building, how do you heat my house, how do you heat the store. Actually, that's only a small part of the problem. The real problem is getting rid of the heat. So solar energy, which is a specific subject having to do with energy conservation, is not treated per se as an item in the building's code. Solar energy is a side area that we don't really know how the Administrative Building Council in the state of Indiana is going to fit. Solar energy, I suspect, is going to be, when it finally gets its impact, I think you're going to see in the Producers' Council presentation, it's going to follow mine. There's going to be a great deal dictated by the kind of equipment that the manufacturers are able to test, get into production and sale for your use in design. I think that's, again, a little bit of a shock that younger architects find when they go out to practice, that the design of buildings has a highly theoretical aesthetic quality and value and a great appeal, and are sometimes dismayed to find that the parameters that are put around a specific application of needs for a particular building aren't as free and liberal as they thought they might be, that they're circumscribed by building codes of all kinds and available materials, available products. Now, the really innovative architect and the firms that are geared to practice that kind of architecture manage to handle that dismay by being free thinkers and attempting to do their own designs in many ways, which is great. Not everybody's qualified to do that. So many architects in the actual practice of their art find that they are dependent, highly dependent upon the products that are made available to them in the design of that building. I have an idea no less will apply in this matter of solar energy. Of course, the passive uses, as demonstrated this morning, will come again this afternoon, about orienting the building for maximum heat input and also at the same time minimum heat input, trying to get it all at the right time so you get the heat at night and the cool in the day. Is probably going to end up more in a dynamic deal where you'll do everything you can to design your building to be as efficient as possible on the solar basis. But in its actual operation, final design, you will be using some kind of a mechanical apparatus in the way of a pump or whatever, or fans, to make it more efficient. The American public got pretty dependent on their comfort. And the idea of having a natural draft through a building from the floor register on one side out through a ceiling high vent on the other wall will still a far way away from the kind of comfort that we expect in our buildings and in our work. So I do think that, and you'll see later on, that I believe solar energy is going to be a secondary development, which will be preceded by the codes first of all. Then the emphasis will be how, for example, if you as an architect undertake a performance-oriented building and you're given a certain allowance of energy to use in that building, that you can supplement that in various ways. For example, if you want to have a large window expanse, which may be relatively inefficient in the conservation of fuel, you may be able to offset that by introducing some other factor so that your end product will meet the code requirements. I don't know how many of you are aware of this, but I ran across an item in the Engineering News Record just 2 weeks ago, I believe it was, that, for example, the state of Minnesota had an architectural competition for a rather large addition to the state capitol for offices in the area of 350,000 square feet, which gets to be pretty good sized building. The winner of the competition came up with an underground design, and to the best of my knowledge, that's the design they're proceeding with, unless somebody here has some facts that contradict that. The state of Minnesota is going to proceed with 350,000 square foot addition to the state capitol underground. It seems to me the article describes something like going down 60 feet underground. There's several layers, several stories. an engineer of my acquaintance who happens to be sitting here in this audience called me several weeks ago and said some time ago he had made a study of the efficiency of an underground factory. And in those years, with fuel prices being what they were, it was the idea was fine, but it was economically impractical. And if I state this wrong, he's going to get me after the meeting. But he said just a few weeks ago he had run through a comparable study again, taking into account the contemporary situation, and found out it wasn't so impractical at all. So taking in as architects, exercising your creativity, see the advantages perhaps of being able to put the operating area of a building underground and using the surface elements for whatever, whether it be parking or landscaping or beautification or whatever. Quite a thing. Now, putting a structure underground gets very complicated, for example, on such things as fire safety. On the other hand, it may be great for equalizing the temperatures for air conditioning and heating. But anyway, that's the kind of thing that is facing this audience, whether you're an alumni out as a practitioner, whether you're a middle-aged practitioner coming here to try and keep up, or whether you're a student starting. We're going to see beginning in the next year, beginning now, a brand new element in your design factor which has never before been existent. One of the more discouraging things about the practice of architecture and engineering, as any practitioner will testify, is the economics of producing a building that will satisfy an owner in its first cost, who has to pass the buck on to some financing institution who insists that he can't spend only a certain amount of money first cost to build his building. And you find out that suddenly your wings are clipped and you can't do half the things you'd like to do to produce what you're sure would be a far more efficient building for that owner. And it is one of the frustrating things about practicing architecture. Now, however, we've got a whole new ballgame. We've got a whole new ballgame because now with the energy and its long-range use and cost as a necessary factor, we can start to look seriously. Matter of fact, we're mandated to look seriously at life cost cycles. That if you can produce the overall cost of that building to be at a level which is competitive, you got it made. I'm sure it's going to be stimulating to the architects. It's going to be stimulating to the younger group of people here who are going to hit their new employers with some ideas and not knowing what they can do. Of course, that's progress. But I do foresee an exciting time ahead. And I foresee that we'll be able to look back, for those of us who are still alive 30, 40, 50 years from now, and recognize the beginning back to this day of a whole new period in American and contemporary architecture. So I'll be very happy. I think my time is up, however, to answer any questions, but I hope that I've told you something that will be of interest and will be useful to you. And our offices in Indianapolis are always open. The telephone is always open to those of you who want to call for more specific information. Thank you.